Given the electronegativity values below, which of the following molecules has the most polar bond? And then we have like a multiple choice here. Would it be methane, CH4? Would it be carbon tetrachloride, CCl₄? Would it be just hydrogen gas, H2? Or, I guess, hydrochloric acid, HCl? Well, they do give us a lovely chart here, right, of each individual element and its respective electronegative values. So let's find out which is the most polar bond. Now, anytime that you're talking about anything about polarity, so whether it's polar, whether it's nonpolar, whether they're just saying polarity, whether they're saying something about electrons, about pulling, whether they say dipole moment, this all comes from electronegativity values. So that's the property that we have to go to. So it's not ionization energy, it's not electron affinity, not atomic radii, it's your electronegative periodic trend, or if they give you specific numbers like this, we're just going to take the numbers. But now, we want to find out which one is the most polar bond. What they gave us were the overall molecules, but we got to find out what's the actual bond within here. Now, we don't need to know specifically how to draw the correct Lewis structure. That's questions in a different topic on the website, which if you guys aren't on the website, check out glazersguide.com. Link is in the description. If you want to learn Lewis structures, you can head on over there. But in this case, we just got to find out what the bonds are, right? Well, in a CH4 molecule, I have one carbon and I have a bunch of hydrogens. So it would make sense that if I'm trying to bind the carbon with something, it would have to be with at least one of the hydrogens. So that would be the bond for this one. It would be a CH bond. And the same type of idea for CCl₄. I have one carbon, the carbon has to be bound to someone, and it's going to be one of these chlorines. So this would be a CCl bond. We keep going. This is only two hydrogens, so I definitely know that it would be just one hydrogen bound to one hydrogen. That's the bond there. And then for this one, it's H and Cl. So there's that bond. Once again, I do not have to put in any lone electrons. Nobody cares. Nobody cares for this type of question. We're just getting the bonds. Now, let's write the respective electronegative values for each element. So all my carbons I see, carbon's electronegativity is 2.5. So 2.5 for here and 2.5 for here. We got hydrogen is 2.1, so 2.1, 2.1, 2.1, and 2.1. And then chlorine is 3.0. Okay. Now, in order to find out the most polar bond, we take those electronegativities and we find out something called a electronegativity difference, which means that we're just performing subtraction. But in order to find out the true difference, always know that it's an absolute value, which means that the electronegativity difference will always be positive. So if you do subtract your two numbers and you get a negative value, just make it positive because it's always the absolute value. So in essence, in my mind, for the first one, I'll take the 2.5 and I'll subtract from 2.1 and I get 0.4. This one, in my mind, is just going to be a little bit flipped because always for electronegativity, the easiest way to go is just minus the high number from the low number. So I'm going to take in my mind 3 minus 2.5, and I get 0.5. 2.1 minus 2.1 is a big fat 0. And then, once again, I'm going to rework this in my mind. 3.0 minus 2.1 is 0.9. These difference values are going to tell me who is the most polar bond. Now, if you are having a polar bond, just know that you do have an unequal distribution of electrons in the bond. One atom is pulling the electrons towards itself. And the most polar bond, just know that if, maybe I'll put it down here, if we are describing that a bond is polar to begin with, the consensus is that you have to be in between 0.4 up until 1.8 for your electronegativity difference. So if you aren't even in that realm, you are not classified as polar. So right off the bat, I mean, you could start knocking off numbers, right? Like, for example, this guy's big fat 0. This would be classified as non-polar. There would not be a pull. Everything is even Steven. Nobody won, nobody lost. It was a tie. This one is, very, very, very close to it. You should be a little bit more than 0.4, so maybe we'll say like 0.5, but maybe we'll say, I guess, greater than 0.4, 0.45, but that's okay. The idea here is the more polar you are, the higher end of the scale you are at. Maybe we'll say you have to be greater than 0.4 up until 1.8. Now, let me just pull this in. We'll close this parenthesis out. So I'm down between a 0.4, a 0.5, and a 0.9. The more polar bond you are, the higher end of that scale you are at. So the higher value. Out of these, can you tell me which one would be the most polar? Yeah, you're absolutely correct. It is HCl. That means that there would be the most pull of electrons in this bond. The 2 electrons would actually be going more towards the chlorine, because chlorine is more electronegative than its hydrogen. You always pull towards the more electronegative element. And that's it. I hope this helped. Thank you so much for viewing the video. Subscribe to the channel, like the video. Just gets the word out there that this channel exists. And yeah, keep working hard. Keep crushing those exams. And if you guys want more practice, head on over to our website. The link is in the description below. My brother and I, we've created all these questions. We've done all these video solutions. We've done the deep dive videos for you guys. It's just the 2 of us. So come on over. Come hang out. Come get your favorite drink, favorite snack, and let's learn. All right? I'll see you soon, and have a great day.
For more practice and for more fun, go to glazersguide.com.
And for more practice and for more fun, come on, go to glazersguide.com.